Okay, hi everyone. In this video, I'll be going through chapter 3 of for Sec 3 G2 Math. How do we draw quadratic graphs? Okay, so for this worksheet, you will need to have your graph paper with you. So please make sure you have your graph paper with you as well as a pencil to draw the graph required for today. Okay. Okay, let's begin. So today we're going to learn how to draw graphs of quadratic functions. So when we draw a graph, there are some steps we must follow very closely over here. So let's look at example 1. Okay, this question will be answered on graph paper. Okay, so let's first do example 1a first. Copy and complete the following table. So over here, this table here gives us the value of x from negative 1, 0, 1, 2, all the way to 5. And then I have a y here, and the y value is defined by x squared minus 4x plus 4. So you are supposed to copy and complete for following table. How do you fill in the table? You are supposed to find out what is the y value when x is negative 1. What is the y value over here when x is 0. So how do we do that? Simply press in your calculator over here. Okay, over here, I would like you to try it by yourself first. Use this expression over here. Replace your x by negative 1. What do you get? So for this case over here, this should be negative 1 square minus 4 times negative 1 plus 4. Okay, press this in your calculator. Tell me what you get. You should get 1 plus 4 plus 4. I should get 9 over here. Okay, I should get 9. Okay, next thing over here is 0. So try by yourself. Over here, I should put 0 square minus 4 times 0 plus 4. I should get 4 over here. Okay, so please do the same thing. Fill in the blanks here very quickly. Okay, you can pause the video over here to finish up filling in. Okay, then I'll continue over here. So if you fill up correctly, you should be able to get these answers over here. 1, 0, 1, 4, 9. Okay, so now the next part on a sheet of graph paper, they say that on a sheet of graph paper, draw this graph from x whereby x range is from negative 1 to 5 using a scale of 2 cm to 1 unit on the x-axis and 1 cm to 1 unit on the y-axis. So over here, I would like you to take your graph paper over here, copy down your table of values on the top right side of your paper, use a pencil and ruler, draw very clearly your table, and then fill in from part A, the table of values which you should have, at the top right of your graph paper, I should get 9, 4, 1, 0, 1, 4, 9. Okay, then I would usually like to write as good practice the scale, what is the scaling of this graph, and the y equation, the equation of the quadratic graph. Okay, then once I've done that, now I want to plot the graph. Okay, so over here I'll draw the x-axis first. X-axis is from negative 1 to 5. Okay, and your y value is, you notice this y value here is from the smallest number is 0 all the way to 9. So over here, how will I draw my axis? I will draw my x-axis like this. I would simply draw, let's say, this line over here. Okay. Okay. I can stop somewhere. Maybe out here. Okay. Then maybe I would now draw this is my x-axis. Now I draw my y-axis. Please draw this with me. Your y-axis should be a vertical line like this. Okay. Okay, please use a ruler. If you do not use a ruler, you will redraw the graph again. Okay. Y-axis, we label this as y. Okay. Then we label your origin as 0. Okay. So then now we can follow the what the question say. X-axis 2 cm to 1 unit. So if you were to use a ruler, you will measure that one big box like this is 2 cm to 1 unit. So meaning that every 2 cm I make a marking here, 1. Every 2 cm make another marking, 2. Okay, so I can mark out all the way until 5. 3, 4, 5, which is what the x-axis range is until, from negative 1 all the way to 5. So I'll mark out negative 1 as well over here. I mark out here as negative 1. Okay. Now I mark my y-axis. My y-axis is from 0 all the way to 9. So the graph question say that 1 cm to 1 unit on the vertical y-axis over here. So over here should be 1 cm to 1 unit. So meaning that over here, every 2 cm, this is 2 cm, it should be 2. 2 cm should be 4. Okay, you must follow the same scaling as what the question asks you to draw. 6, 8, and this one will be 10. Okay, very simply. Okay, my graph is too long. Okay, I don't need so long, so I can leave the top over here, leave it as y. Okay, now I've done that. My next step now is to simply plot in the points based on my table of values over here. Okay, so over here, this is my table of values. How do I plot my coordinate? -1, 9. This is one coordinate. I mark out this point on the graph. X is -1, y is 9. I check my graph over here. When x is -1, which is this value here, y is 9, which is this value over here. So therefore, this is my first point. I mark out with a cross. Next point, 0, 4. When x is equal to 0, so my x-axis value is here, okay? When x is equal to 0, it means this value over here, y is 4. So it is this point over here. I'll mark it with a cross. Okay, next one, 1, 1. So very simply, x-axis 1, y coordinate here should be 1. Okay, so over here I put a cross. This is 1, 1. Then from there, x-axis is 2, x-axis is 2, y-axis is 0. So when x is equal to 2, y is 0. So therefore, it is this value over here. Then continue from here. When x-axis is 3, y value is 1. When x-axis is 3, y value is 1. So therefore, it is this point over here. Okay, 1. Then next point, 4, 4, it will be this point over here. And last point, 5, 9. So when x is 5, y is 9. So it is this point over here. This value here is 9. Okay, so if you can follow the same steps as me, you should get this same curve shape. My next step is to fill in the blanks. I will draw, using my pencil, a smooth curve. Take note, your curve must be smooth to connect all these points together. Okay. Okay. Okay, I'll try my best to make this curve smooth. Let me see if I can. Okay. Yeah. It looks smooth. Yeah. I think this is okay. Okay, take note, when you draw a curve, should be pencil, one line. I should only see one line, not a sketch like you draw like some sketch like this. This is not accepted. It should be one straight line, and the curve should look very natural and very smooth. Okay. Okay, then once I've drawn my curve, my next step is to label your graph. So over here, what you should do, okay, so this table over here will tell you very clearly what you need to do when you want to, all these different steps that you should do when you do your working over here. So you can see when I drawing a graph, pencil, okay, draw table of values in the top right hand corner, plot coordinates with a small cross. Take note, there's a cross. Let me highlight this here. This is not a dot. We cannot use a dot. We should always use a cross like this to mark out points. Okay, not dot. Okay, label x and y axis. Okay, make sure your curve pass through all your coordinates that you mark out. Then next step, label the graph equation. So over here, this graph equation is y equals to x squared minus 4x plus 4. So I'll label at the side over here. Y equals to x squared minus 4x plus 4. Okay, x squared minus 4x plus 4. Okay, and that's it. We have done part B, which is to draw the graph. Okay, then now let's look at part C now. Use the graph to find the coordinates of the points where the graph meets the x-axis. So you look at this part over here. Where does your graph meet your x-axis? This is my x-axis, right? The graph only touches your x-axis at this point over here. One point. Okay, so therefore to answer this question over here, maybe let me move my graph up. You can answer your question in the space below. If there's no space, you can also write on your graph paper over here. Okay, this is for part C. Part C, okay? Okay, the graph meets the x-axis. X-axis at this point here. This point, the coordinate is 2, and the y value is 0. This x value here is 2. The y value here is 0. So therefore, the coordinate will be 2, 0. Okay, this is for part C. And now the question says, for part D, state the minimum value of y. That means what is the smallest y value of the graph and the value x value when it occurs. So if I were to look at this graph over here, the y value will range from, let's say, 9 all the way down to 0, all the way back up to 9. So what do you think is the smallest y value? If we were to analyze this graph, you notice that the smallest value is actually 0. Because this is your y-axis, right? Your y-axis represents what value your y is. And the smallest y value over here, this graph will continue to go upwards. But the smallest y value, it is this point over here. And this point is when the y value here is 0. Okay, so therefore, to answer the question for part D, okay, the smallest, okay, or what the question say, the minimum value of y, okay, is equal to 0. And then the question says, state the value of x which it occurs. So when y is equal to 0, this point here, my x value here is 2. Okay, so over here, it occurs when x is equal to 2. Okay, great. And with that, we have done example 1. Alright, so now let's look at example 2 now. Example 2, using a scale of 2 cm to 1 unit on the x-axis and 1 cm to 1 unit on the vertical y-axis, draw this graph over here. Okay, so over here, what you need to do is simply first, we will follow the steps. Okay, first step, when I do this, let me write down the scale so it's clearer. So take out a new piece of graph paper. Okay, we highlight some important information from the question here first. They say x-axis 2 cm to 1 unit, y-axis 1 cm to 1 unit. So in case I forget, I'll write it over here. Okay, or maybe I can just copy paste. You all need to write from here. My scale is the same. I will copy this. Okay, I'll put this over here. Okay, I'll write this on my top left side of the paper. Scale 2 cm to 1 unit. Okay, next step is to draw my table of values. So how do I draw my table of values? We draw it on the top right of the graph paper. They say x is from -4 to 3. So I'll write over here on my top right of my graph paper. I start with the highest x value here first. 3, 2, 1, 0. You notice I will leave 5 small boxes for one box so that I can see it clearly. So between 2 cm, I should have 2 numbers spread out evenly. Okay, and the x value is from -4 to 3. So I'll count down from 3 all the way to -4. -1, -2, -3, -4. Then here I'll write x. Okay, that means the bottom column here will be y. So let's draw your table here on your paper. This will be my table of values. Then you'll use a ruler and pencil to mark out this table very clearly over here. Okay. Okay. Then I can now draw the lines. Okay, then now after I've drawn my table, my y row here, I haven't put in the numbers yet. How do I find my y values? Same as previous example, I look at the equation. The equation of this question here is y equals to 6 minus x squared. So to be clear, let me write the equation down. Y equals to 6 minus x squared. Okay, so now how do I find my y value? Very simply, over here. Okay, in case you've forgotten, here I want to find the y value when x is -4. So over here, this working over here is simply y will be equals to 6 minus, I replace x by -4 minus -4 squared. Okay, press this into your calculator. What do you get? Okay, if you press this correctly, you should get -6. Okay, now you do the same thing for the rest over here. Please pause this video, fill in this entire row over here by yourself using the same steps. Replace your x by -3, -2, -1 all the way until we reach 3. Okay, you pause this video first to finish this up. Okay, I'll continue over here for now. So if you press correctly over here, you should get 0, 4, 6, 6, 4, 0, -6. Okay, if you get these values over here, then now my next step is to draw my x and y axis. So over here, if you look at this graph, okay, I want to draw my x-axis over here. X-axis is from -4 to 3. Then my y-axis is -6 to the smallest number is -6. The biggest number is, let's say, 6. So that means if I were to draw my y-axis should be somewhere at the center. So you can follow mine over here. Let's say if I draw my y-axis somewhere maybe over here. Okay, this is my y-axis. Okay, then over here my x-axis, maybe I can draw somewhere over here. Maybe I'll draw over here. Okay, so after I've drawn this over here, now I can label my graph. Okay, so first step, once you draw an axis, label your x and y axis first. Now I've done that, I label the middle, the origin here, whereby we know that the value here is 0, 0. This is the middle of your two axes. Then now we follow the scale. The scale say 2 cm to 1 unit on x-axis. Means that every 2 cm over here, this is 2 cm, I mark out 1 unit. Here is 1, here is 2, here is 3. I mark out backwards. Okay, so over here, I have -1, -2, -3. Also, you need to have until -4. So I'll extend out my axis over here, draw until -4. Okay. Then for my y-axis, 1 cm to 1 unit. So I mark out over here. Okay, I have 1 cm to 1 unit. So every 1 cm, 1, 2, 3, 4, 5, 6. Any model? Okay, from 6 to -6. So I can mark out -1, -2, -3, -4, -5, -6. Okay. Okay. Then now I've done that, I can now start to draw my graph. Okay, so remember again how we draw a graph up. Plot your points based on this one column like this. Let me highlight. One column like this is 1 point. So first point, -4, x value -4, y value is -6. So I check x-axis over here. -4 match to -6 on the y-axis. This is my first point. Okay. Next point over here, -3, 0. So I check my x-axis, -3. Okay, and the y value is 0. So that means it is this point over here. Next one, -2 and 4. X value -2. Then the y value is 4. So it's this point over here. Okay. Then let me do a bit faster now, since I think you should be able to grasp. -1, 6. Then 0, 6 over here. Then 1, 4, 2, 0, which is here. 3, -6 over here. Okay. Maybe we can mark out even more on your y-axis. I have 7, 8. Okay. So now I'll draw a graph that connects my points together. Okay, so remember to try your best. You can either use a curve ruler, draw your points such that it connects all the coordinates very nicely. Okay, I will try my best to make this a smooth curve. Oops, this is not that smooth. Wait, okay. And now I think I need to make it more smoother. Okay, let me try to connect the rest. Okay, I have no curve ruler, so I'm trying to make this look as smooth as I can. Something like this lah, okay? Okay. I think this looks smooth. Yeah. Okay. Okay. So over here, remember once I've drawn my graph, my next step is to now label your graph. So over here, I'll label this graph as the equation y equals to 6 minus x squared. Okay, and like that, we are done with example 2, part A. Okay, so now let's look at the next part. Once you draw this graph, we look at the next part. The question says, now use your graph to find the value of y when x is equal to 0.7. So next part over here, now let me look at my graph. I want to find the value of y when x is equal to 0.7. So let's now make out marking. Where is 0.7? I look at my graph, this is 0.7. Okay, so now I'll draw a dotted line upwards. I want to find the value of y of the graph when x is 0.7. Okay, and I map out to this point over here. 0.7, then now I check to my y-axis, I draw a horizontal dotted line to check. What is this value over here? And you can see that this value over here is actually 4.8. Because each division is 0.2. So therefore, for example 2b, part 1. Okay, example B, part 1. Okay, when x is equal to 0.7, y is equal to 4.8. Very simply, this is for part 1. Okay, then next one, part 2. Find the value of x when y equals to negative 2. So we do the same thing. When y is equal to negative 2, okay, let's write that over here. When y equals to negative 2, okay, I will now draw another dotted line at when y is equal to negative 2. So I'm looking at this value over here. This is my y-axis. Negative 2 is this value here. I will draw now a horizontal dotted line when y is negative 2. And I'll cross-check with my graph. When y is negative 2, what is the value of x? Okay. Okay, so then now I check over here. Based on this part over here, I will now map out. I'll draw a dotted line upwards. This is the line y equals to negative 2. Okay. I will now map upwards to check with the x-axis what is the x value. So over here, I'll draw a dotted line upwards. Okay. Then same thing for this part over here. I'll draw a dotted line upwards to check. Okay. And you notice that this value over here is 2.4. This value on the left side over here is negative 3.4. Okay, about there, it's about negative 3.4. So therefore the answer, when y is equal to negative 2, my x value is x is equal to negative 3.4 or, let me write out properly, or x is equal to 2.4. Okay. This is for part B. Then next part, write down the coordinates of the points, part C, of the points where the graph intersect the x-axis. So let's check over here. When the graph intersect x-axis, this is my x-axis. The graph to cut the x-axis, this is my graph over here. It is these 2 points over here. So therefore, write down the coordinates. We know that this point over here, coordinates, the x value here is negative 3. Y value is 0. Because any point on your x-axis, the y value is 0. So therefore, for part C over here, part C, I can write out the answer. Okay. Points, write down the coordinates of the points whereby the graph intersect x-axis. So therefore, I can write x-intercepts are, first point, we look at the left one over here. This point here, negative 3, 0. Second point, this point over here, it's 2, 0. Okay, these are the x-intercepts of the graph. Then next one, find the maximum point of the graph. So therefore, I have to look at this graph over here. Maximum point, I will see that it's somewhere about here, this point over here. Okay, so therefore, if I were to look at this maximum point over here, let me make a marking. I make a mark. This is my maximum point. Right, let's write down the coordinates. Coordinates is simply over here. I I check what's the x value here. This value will be negative 0.5. Okay, so this is negative 0.5. And the y coordinate value, we can check over here, probably about 6.4. 6.4. Okay, so therefore, we can say that for part C, okay, the maximum point of the graph, okay, this is part 1. Part 2, max point, the coordinate is simply negative 0.5, comma 6.4. Okay, this is for part 2. Okay, and for the last part, equation of line of symmetry, a line which the graph will be symmetrical about. I hope you can see that this line over here, maybe let's use a different color, will be this from the maximum point downwards. This line is your line of symmetry because you see your graph is symmetrical on either side. Okay, so therefore, since this is a vertical line, we just need to find what is the x coordinate of this line. And based on my maximum point, I know that this point over here, if I check my x-axis, it cuts at negative 0.5. So therefore, equation of line of symmetry, I got no space here. Let me write over here. Draw a label of the equation of line of symmetry. So over here, we will draw, using a pencil, I'll use an orange line to draw this line over here. Okay, draw this line to your graph paper. This is your line of symmetry. Okay, I will now label this line. X equals to negative 0.5. This is your line of symmetry. Line of symmetry. Okay. Okay, I hope you are clear on how do we obtain this now. The equation of the line of symmetry is simply x equals to negative 0.5 obtained from your maximum point of the graph. Okay, and this is for example 2. Okay, if you're okay, let's move on to the last example of this worksheet, example 3. Okay, example 3 over here is the application question now. How do we apply this graph question into more word problems? Okay, so over here, let's look at this example 3 first. David hits a football with his head. The height of the ball, h, after t seconds is modeled by this equation over here. What is the height of the ball when David first hits the ball? So over here, when David first hits the ball, the time would be equal to 0. So over here, of part A, you can simply answer the question. Okay, when David first hits the ball, the time t is equal to 0. So therefore, h is equal to, replace your t to become 0. It will become 2 plus 5 times 0 minus 5 times 0 squared. Final answer is equal to 2. So therefore, the height is equal to 2 meters when David first hits the ball. Okay. Then now, next part, copy and complete the table of values over here. So same as what we have done in previous examples, please, when t equals 0.2, please go and calculate yourself what is the h value. You sub in, reminder again, this will be sub in, negative 5 times 0.2 square plus 5 times 0.2 plus 2. You sub into this equation over here. Okay, use your calculator. Can you calculate these 3 values? Okay, you can pause the video here first, calculate the values, then come back to check. Okay, so if you have calculated the values over here, I should get 2.8, 3.2, 3.2, 2.8 here as well, and 2 and 0.8. Okay, so now once I've drawn my table of values, okay, now I can start drawing my graph. So same steps, they say that use a scale of 2 cm to represent 0.2 seconds. Draw a horizontal t-axis from 0 to t which is to 1.4. So over here, let's label this scale so that we are clearer. Okay, what does the scale want based on this question? They say that the horizontal, now it's not x-axis anymore, but they call it t-axis. But it is the same. So over here we call this t-axis, the horizontal axis. The scale is 2 cm to 0.2 seconds. 2 cm to 0.2 seconds. Okay. 0.2 seconds. And the vertical y-axis, let's highlight over here, 2 cm to 2 seconds for horizontal t-axis. Then for the y-axis, I use 2 cm to 1 meter for the vertical h-axis. Instead of y, we call this h now. So therefore, h-axis, let's write out. H-axis, this is your vertical axis. It is 2 cm to 1 meter. Okay. Then now I can fill in the table of values based on these values over here. So now on the top right of your graph paper, please now draw in your table of values. Okay, we always start from the highest value here. 1.4, 1.2, 1.0, 0.8, 0.6, 0.4, 0.2, 0. Then I have T and H. Okay, then after I have 2, 2.8, 3.2, 3.2, 2.8, 2, 0.8, and negative 0.8. Okay, so now once you draw a table, please draw it nicely. Pencil, ruler, draw your table clearly. Okay, so I'll draw out the table clearly over here. Well, this takes some time, so I hope you have patience to finish this. Okay. Yes, okay, I've drawn my table of values now. Very good. Okay, then now remember what do I need to have over here? I should have my equation. So you check equation of the graph is h equals to negative 5t squared plus 5t plus 2. So I'll write over here h equals to negative 5t squared plus 5t plus 2. Okay, so now I can start drawing my axis now. Okay, your x-axis is this t-axis over here from 0 to 1.4. We start from 0, so don't need to have negative. So I can put my vertical axis somewhere around about, let's say, okay, maybe I can draw it over here. Yeah. Okay. Okay. Then I can now draw my the h-axis, which is, yeah, so this is my, check, don't get confused. From the question here, say horizontal is t-axis, vertical axis is h-axis. So that means in this graph here, this vertical axis is called h. Your t-axis is your horizontal axis. Okay. We can draw it to be, let's say, here. Here, okay. Okay. Then we label this. We label this as your horizontal t-axis. Okay. Then now let's label the points. We start from 0 first. My t-axis 2 cm to 0.2 seconds. So therefore, if I were to label over here, every 2 cm is 0.2. So this is 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4. Okay, this is your horizontal t-axis. Then the vertical h-axis, I have 2 cm to 1 meter. So therefore, I have over here, is it 2 cm to 1 meter? Okay, so I will have, this will be 1, this will be 2, this will be 3, this will be 4. Then backwards, I have -1, -2, etc. Okay, so now once I've drawn this axis over here, I can now plot the points. So can you now try by yourself? Plot the points based on my table of values and have your graph. Okay, so first value is 0, 2, t value is 0, the h value is 2. So it would be this point over here. Then 0.2, 2.8, 0.2 match with 2.8, which will be this value here. Okay, 2.8. Okay, check your own graph carefully. 0.4, 3.2, I have 3.2, which is this one here. 0.6, 3.2 here, 0.8, 2.8, I have this value here, 1.02, I have this answer here, okay, 1.0, 2, then 1.2 I have 0.8, 1.2 I have 0.8, which is over here, then 1.4 I have negative 0.8, which is over here. Okay, negative 0.8 will be here. Okay. Okay, then once you have done your sketch, you can now sketch your graph by connecting the points together. So connect nicely, okay. Your points, all the curves should touch each other. So I should have something like this. Okay, I'll do my best. It may not be the most. Ayo. I think it can be better. Yeah. Okay, something like this. Okay. So once I've drawn this curve over here, okay, we have now answered this question. Okay, draw the graph for part B, part 2. Okay, so now we can now answer the questions. Use your graph to estimate. Wait, before that, I almost forgot. Remember, once you draw a graph, you must always label. We label this graph as h equals to negative 5t squared plus 5t plus 2. Okay, so now let's answer the questions. Use your graph to estimate the time when the ball strikes the ground. So when the ball strikes the ground, it means that h, this height here, remember what is h? H is the height of the ball from above the ground. So when the ball hits the ground, my h will be equals to 0. Okay, so over here, C part 1. Okay, C part 1. When ball hits ground, the h will be equals to 0. So we check the graph. When h is equal to 0, over here we notice that when h is equal to 0, this value over here will be t is equal to 1.3. So we can label over here. This value over here will be about 1.3. Okay, so when h is equal to 0, when h is equal to 0, the time t is equal to 1.3 seconds. Okay. Next part, let's look at the next part over here. Let's estimate the height. The question here says, part 2, find the maximum height of the ball above the ground and the time when this occurs. So we just need to look at the graph, find the maximum value. You can see that amongst this shape over here, the maximum value is probably this point over here. So let's mark out this point and write down the coordinate. This point, okay, coordinate x value first. I check what is the x value. This value over here, can mark out. Let's do a dotted line down using a ruler. I see that this value here is 0.5. So I'll label 0.5. Then now I check the y coordinate value. Use a ruler, okay, mark out, dot it to your y-axis. Then read the y value over here. You should tell that this should be 3.25. Okay, therefore I can label this as 3.25. So this means that over here, maximum point. The question here says maximum height of the ball. So if you were to use my graph, your own graph may be different, but the number should be about the same. Maximum point, the coordinate is 0.5, 3.25, which means that over here, the maximum height of ball is equal to 0.5 meters, and this occurs at 3.25 seconds. Okay, this is for C part 2. Okay, then the last one over here, find the duration at which the height of the ball is at least 2 meters above ground. So Find the duration which the ball is at least 2 meters above ground. So let's look at my graph over here. I look at this h represents the height of the ball. For the ball to be 2 meters above ground, let's draw I trace this graph. Let's look at this. This is the height of the ball. Okay. How long is the ball at least 2 meters above ground? From the 0 second, the height of the ball, because the guy kicked the ball, right? It goes up all the way until it hits 2 meters here again, then it goes downwards. So how long do you think the ball is at least 2 meters above ground? We can see that it will hit 2 meters again at 1 second. After 1 second, it will go below 2 meters already, right? So therefore, from here, we can say that, conclusion for part 3, okay, the ball is at least 2 meters above ground from t equals to 0 second to the time equals to 1.0 seconds. Okay, that is the duration at which the ball is above, at least 2 meters above ground from 0 seconds to 1 second. Okay, and then now for the last part over here, what do you think is the value of t? So over here, t means over here the time in which the ball hits the ground. So over here, if I were look at this, right, this t here, this t is this unknown thing over here, this capital T. Okay, so this is a challenging question. What do you think is the value of t? So over here, the ball imagine the ball leaves David. Okay, then after David kicks the ball drops back to the ground. So what do you think is the maximum t, the interval in which the ball is moving? After how many seconds after David kicks the football? So if we were to measure based on this graph over here, you notice that over here, can h ever be negative? Because this h is the height above ground, right? And the ball, after it hits the ground, can it go under the ground? You must hit the ball with extreme force in order for the ball to dig underground. So therefore, for part D over here, the maximum time, part D I write over here, okay, t in this case, this t over here, which is the time interval which the ball is being hit by the ball, the maximum time t will be equals to 1.3 seconds. Okay, and this is because the ball cannot travel after it hits the ground at 1.3 seconds. Therefore, for part D, the answer is that the time t is equal to 1.3 seconds, because after this point over here, whereby the ball hits the ground, it cannot go downwards anymore. Okay, and with that, we have finished example 3 from the worksheet. Okay, so with that, I'll just like you to go back and try the practice questions over here first, from your workbook. Okay, then we will continue more on graphs in class. Okay, so this is the end of this worksheet.